Preparing for a Teradata interview can be a challenging task. This video is designed to help you build confidence by providing the top 25 Teradata interview questions and their answers. From basic to advanced levels, these questions cover a broad spectrum of Teradata concepts. The video ensures you are equipped with the knowledge necessary to excel in any Teradata interview. 1. What is Teradata and what are its primary characteristics? Teradata is a widely used relational database management system, RDBMS, suitable for building large-scale data warehousing applications. Its primary characteristics include scalability. Teradata can manage data ranging from gigabytes to petabytes and is capable of handling an unlimited number of users, queries, or data loads concurrently. Shared nothing architecture. Each node in Teradata operates independently, with its own operating system and resources, ensuring no single point of failure. Parallelism. Teradata uses parallel processing to handle a high volume of data. It divides the large tasks into smaller ones and executes them simultaneously, resulting in faster processing. Automatic distribution. Teradata distributes data evenly across all processors to ensure balanced workload and optimal performance. SQL compatibility. Teradata is compatible with industry-standard SQL for defining and manipulating the data. Please note that these are just a few of the many characteristics that make Teradata a powerful and robust data warehousing solution. 2. How does Teradata differ from a basic RDBMS? Teradata is a relational database management system, RDBMS, but it has unique features that differentiate it from a basic RDBMS. One key difference is Teradata's ability to handle large amounts of data across many servers, thanks to its parallel processing capabilities. This allows for faster data retrieval through simultaneous processing of queries. Additionally, Teradata uses a unique distribution method called hashing, which ensures data is evenly distributed across all access module processors, AMPs, leading to balanced storage and efficient data retrieval. Lastly, Teradata provides built-in support for complex data types and non-relational models, which is not typical in a basic RDBMS. This makes Teradata suitable for advanced analytics and big data operations. 3. Explain the concept of parallelism in Teradata. Parallelism in Teradata is the principle that allows several tasks to be executed simultaneously, maximizing efficiency and performance. This is achieved through the use of the massively parallel processing (MPP) architecture, which divides a large job into smaller tasks that can be processed independently at the same time. There are two types of parallelism in Teradata: interquery and intraquery. Interquery parallelism permits multiple queries or tasks to be executed concurrently, each by a different AMP. On the other hand, intraquery parallelism allows a single query to be split into multiple tasks and executed concurrently. This feature of Teradata significantly reduces the execution time and enhances the performance of complex queries. 4. What are the different types of tables supported by Teradata? Teradata supports a variety of table types. One such type is the permanent table, which is the most commonly used. As the name suggests, data in these tables is permanent and stored until it's deleted. Volatile tables, on the other hand, only exist for the duration of the user session. Once the session ends, the data in the table is lost. Next, we have the global temporary table, which is similar to the volatile table, but its definition is stored on the data dictionary. The data isn't shared among users and is deleted once the session ends. Lastly, there's the derived table, created inside the query and doesn't have a permanent existence. Another key type is the set and multiset table. Set tables discard duplicate rows and take more time to insert data as it checks for duplicates. Multiset tables allow duplicate rows and take less time to insert data as it doesn't check for duplicates. Temporal tables, introduced in Teradata 13.10, are used to answer queries for any point in time. 5. Describe the Teradata architecture and its main components. Teradata's architecture is a shared nothing architecture. This means that each node in the system works independently and controls its resources. The architecture consists of three key components: parsing engine, PE, BYNET, and access module processors, AMPs. The parsing engine is responsible for accepting SQL requests, transforming them into steps that AMPs can understand, and optimizing them for execution. BYNET acts as a communication medium between the parsing engine and AMPs. It's responsible for routing messages to the correct AMPs, based on the row hash value. AMPs are the workhorses of Teradata. They store and retrieve data, and perform actions on data blocks. Each AMP manages a subset of the system's data and works independently of other AMPs. This allows for high parallelism and scalability. These components, working together, ensure that Teradata can handle large data volumes and complex queries efficiently and reliably. 6. What is an Access Module Processor, AMP, in Teradata? The Access Module Processor, AMP, is a crucial component within the Teradata architecture that performs all of the database operations. Each AMP operates independently, managing its own set of disks and performing all database operations such as insertion, deletion, retrieval, sorting, aggregation, and joining of data. It's the AMP's responsibility to handle the physical data, including managing and controlling the allocated space. Additionally, AMPs are responsible for ensuring data integrity and recovery in case of system failures. Despite being independent, they work together to execute complex queries, dividing the work evenly and thus reducing the response time. 7. Explain the difference between primary key and primary index in Teradata. Primary key and primary index in Teradata have different functions and characteristics. The primary key is a field, or combination of fields, that uniquely identifies a record in a table. It ensures each record in a table can be uniquely identified and cannot have null values. On the other hand, the primary index is a Teradata mechanism that determines the distribution of rows in a table across the AMPs, Access Module Processors. There are two types of primary indexes in Teradata: Unique Primary Index, UPI, and Non-Unique Primary Index, NUPI. UPI ensures that the data distribution is unique and evenly distributed across all AMPs. NUPI does not ensure uniqueness of the data, potentially leading to skewed data distribution. It's important to note that while all tables in Teradata must have a primary index, a primary key is optional. This is one of the fundamental differences between primary key and primary index in Teradata. 8. What is a virtual disk in Teradata? Teradata's virtual disk is a storage space. It isn't a physical disk but a combination of different physical disks into one logical unit. It's a part of Teradata's unique design that allows for highly efficient data distribution and retrieval. The Access Module Processors, AMPs, in Teradata use virtual disks to store and retrieve data. Each AMP manages its own set of virtual disks and doesn't interfere with other AMPs, which contributes to Teradata's parallel processing capability. If one AMP fails, others can still operate, ensuring high availability and fault tolerance. Virtual disks are optimized for parallel processing and do not have any pre-assigned space limits, meaning they can grow as needed, allowing for flexible and scalable data storage. This feature is particularly useful in big data scenarios, where datasets might grow rapidly. This design also enhances data retrieval speed as multiple AMPs can read data from their respective virtual disks simultaneously. In short, virtual disks in Teradata are an integral part of its architecture, contributing significantly to its parallel processing, data management capabilities, and overall data warehousing performance. 9. How does Teradata handle data distribution across multiple nodes? Teradata uses a unique algorithm, known as the hash function, to distribute data across multiple nodes. This ensures both load balance and optimized performance. When data is loaded into Teradata, the hash function calculates a unique row hash for each row based on the values of the primary index. The row hash is used to determine which AMP should store the row. Each AMP is responsible for a portion of the hash map, and only it can access its assigned rows. This approach allows Teradata to provide swift, parallel access to data. The distribution of data across multiple nodes helps in managing large volumes of data efficiently and ensures that the system can handle complex queries quickly. The approach of evenly distributing data also helps in avoiding any bottlenecks during data retrieval and adds to the performance of the system. 10. What is the purpose of the Teradata Gateway? The Teradata Gateway serves as a critical component in the Teradata system. It acts as a bridge, facilitating the communication between clients and the Teradata database. When an application sends a request, the gateway dispatches it to the appropriate AMPs, Access Module Processors, within the Teradata system. It also ensures the correct sequencing of the responses from the AMPs before sending them back to the client application. This way, it efficiently manages and controls the data flow in the Teradata system, contributing to its high-speed processing capabilities. By providing an efficient communication path between the client applications and the database, the Teradata Gateway enhances system performance and ensures seamless data access and management. 11. Explain the concept of spool space in Teradata. Spool space is a temporary storage area in Teradata. When a user runs a query, Teradata uses this space to store intermediate results, sort data, and perform other operations. Spool space is allocated to every user according to their profile, and it's a critical resource for query execution. If the spool space is exhausted during query execution, the query fails and an error message is returned. Therefore, effective spool space management is important for ensuring smooth and efficient data processing. It's important to note that spool space is not permanently used, it's freed up once the query has completed execution. Managing spool space effectively can prevent system slowdowns and ensure smooth operations. It involves monitoring the spool space usage, allocating sufficient space to users, and optimizing queries to reduce the spool space requirement. 12. What are the different types of joins supported in Teradata SQL? Teradata SQL supports multiple types of join operations. First is the inner join, which returns rows when there is a match between the tables. Second is the left outer join, which returns all rows from the left table and the matched rows from the right table. If no match is found, the result is null on the right side. Third is the right outer join, which returns all rows from the right table and the matched rows from the left table. If no match is found, the result is null on the left side. Lastly, there is the full outer join, which returns all rows when there is a match in either left or right table. The join type used significantly impacts the efficiency of the query. It is essential to choose the appropriate join based on the data at hand and the desired output. 13. How does Teradata implement data partitioning? Partitioning in Teradata is a process that allows data to be stored in separate physical parts or units based on certain criteria. This enhances database performance by enabling parallel processing of queries that are executed on large tables. Teradata implements data partitioning using the partition primary index, PPI. By creating PPI on a table, Teradata partitions the table rows into different portions based on the partitioning expression defined during PPI creation. When a query is executed on a table with PPI, Teradata only scans the relevant partition instead of the entire table, thereby reducing I/O operations and improving query performance. Each partition can be treated as a separate table, which makes data management easier and more efficient. 14. What is the difference between a permanent and a volatile table in Teradata? The vital distinction between permanent and volatile tables in Teradata lies in their lifespan and storage. Permanent tables, as the name suggests, are stored in the database until explicitly deleted. They maintain data across sessions and system restarts, serving as the primary storage mechanism for persistent data. On the other hand, volatile tables are temporary in nature. They exist only for the duration of the user session that created them. Once the session ends, the volatile table and its data are automatically deleted. They are primarily used for interim computations and analyses within a session. Additionally, volatile tables do not require disk space to be reserved in advance. They use the spool space allocated to the user's session. In contrast, the storage space for permanent tables must be pre-allocated and managed more carefully. It's also worth noting that because volatile tables are session-specific, they do not participate in transactions across different sessions. Contrastingly, permanent tables can be accessed and manipulated by all sessions. 15. Explain the concept of BYNET in Teradata architecture. BYNET in Teradata architecture refers to a powerful component that handles inter-processor communication. It essentially acts as a messaging layer between the parsing engine, PE, and access module processors, AMPs. BYNET's primary function is to transmit SQL requests from the PE to the appropriate AMPs and send the response back to the PE. It functions on the principle of point-to-point or broadcast communication, ensuring efficient data transmission and retrieval. This feature makes it unique and a crucial part of Teradata's parallel processing architecture. It's noteworthy to mention that while BYNET appears as a single entity, it's actually composed of two independent BYNETs for redundancy and load balancing purposes, thereby adding to Teradata's robustness and reliability. 16. What are the various Teradata utilities and their purposes? Teradata offers a suite of utilities to facilitate data management, covering a range of functionalities such as data loading, exporting, and backup. Below are some key utilities. 1. FastLoad. This utility is designed for high-speed loading of large volumes of data. It is often used when there is a need to load an empty table. 2. Multi-load. This utility is used for loading, updating, and deleting data. It is capable of handling multiple tables at once, making it useful for complex data manipulation tasks. 3. Overall, Teradata utilities are invaluable tools for managing data in a Teradata environment. They help streamline and automate data management tasks, significantly reducing the time and effort required for these tasks. 3. TPump. Also known as Teradata Parallel Data Pump, it allows near real-time data loading into Teradata databases. 4. Fast Export. As the name suggests, this utility is used for exporting data from Teradata tables. It is particularly useful when there is a need to export large volumes of data quickly. 5. BTEQ. Stands for Basic Teradata Query. It is a utility for submitting SQL queries to a Teradata database. It can be used for both batch and interactive mode. 6. Arc main. This utility is used for archive and recovery tasks. It allows users to back up and restore data, ensuring data safety and integrity. 17. How does Teradata handle concurrent user access and workload management? Teradata utilizes a range of features to manage user access and workload effectively. It employs a combination of load balancing, session control, priority scheduling, and resource partitioning to ensure optimal performance. Load balancing involves evenly distributing the workload across all nodes in the system to avoid overloading any one node. Session control enables Teradata to manage user sessions by limiting the number of active sessions and prioritizing them based on their importance. Priority scheduling allows Teradata to prioritize user requests based on their severity, ensuring that critical operations are executed first. Resource partitioning divides system resources into logical partitions, with each partition reserved for a specific type of workload. This helps to ensure that high-priority workloads are not impacted by low-priority ones. In terms of user access, Teradata uses user-defined access rights and roles to manage who can access what data and what actions they can perform. This ensures that data remains secure while still being easily accessible to those who need it. By utilizing these features, Teradata is able to efficiently manage concurrent user access and workload, ensuring high performance and data integrity. 18. Explain the difference between multiset and set tables in Teradata. Multiset and set tables are two types of tables in Teradata. The key difference between them relates to how they handle duplicate records. A set table does not allow duplicate records. If you try to insert a duplicate row into a set table, the action will fail. On the other hand, a multiset table allows duplicate records. If you insert a duplicate row into a multiset table, the operation will be successful. This fundamental difference can impact the performance of your Teradata operations. Because set tables need to check for duplicates every time a new record is inserted, operations on set tables can be slower than on multiset tables. However, it's essential to note that this does not mean one type of table is inherently better than the other. The choice between multiset and set tables depends on the specific requirements of your database and the nature of your data. If your data contains a lot of duplicates and you want to maintain them, you might prefer to use multiset tables. But if you need to ensure that your data is unique, you might opt for set tables instead. It's all about finding the right tool for the job. 19. What is fastload in Teradata and how is it used? Fastload in Teradata is a powerful utility used for high-speed data loading into empty tables. It operates in two phases. The first phase involves sending SQL requests to Teradata from a script file, parsing data records from the data file, and then sending them to Teradata. The second phase is where Teradata applies the changes to the target table. One unique aspect of fastload is its ability to load large volumes of data swiftly. It does this by dividing the input data file into 64K blocks and then sending these blocks to Teradata. This functionality ensures that Teradata uses its parallel processing capability to the maximum, resulting in a significantly faster data loading process. Fastload also has error handling capabilities. It can detect and report errors that occur during data loading, making it easier for users to troubleshoot and resolve issues. It is highly beneficial when dealing with large datasets, where manual error detection would be time-consuming and inefficient. Remember, fastload only works with empty tables. If you need to load data into tables that already contain data, you would need to use a different utility such as multi-load. 20. Describe the different types of indexes available in Teradata. Teradata supports several types of indexes which are beneficial for data retrieval and query optimization. Primary index, PI, ensures data distribution across all AMPs and optimizes data retrieval. Secondary index, SI, aids in data access when PI is not involved. Join index, JI, speeds up the join operations by pre-joining tables. Hash index creates a one-row hash table and is beneficial for equality conditions in a query. Partition primary index, PPI, allows Teradata to skip unnecessary partitions and enhances query performance. Each index type has its own advantages and disadvantages, and the choice of index depends on the specific requirements of the database design and query workloads. 21. How does Teradata implement data compression? Teradata uses a technique known as automated data compression, ADC, to reduce the amount of physical storage required for data. It uses a dictionary-based compression method that replaces repeating values with shorter, 8-byte reference values. This process takes place during data loading and is completely transparent to end users. ADC is most effective when applied to columns that have a limited number of distinct values that are repeated frequently. It can significantly reduce the amount of space required to store this type of data, leading to increased efficiency and improved system performance. ADC does not require any changes to existing SQL queries or applications, as the compression and decompression processes are handled automatically by Teradata. However, it's important to note that while ADC can save space and improve performance, it also requires additional CPU resources to perform the compression and decompression operations. Therefore, the benefits of ADC should be weighed against the potential impact on system performance. In addition to ADC, Teradata also supports block-level compression, BLC, which can further reduce storage requirements, particularly for large tables. BLC operates at the disk block level and is most effective for large, rarely accessed tables. 22. What is the purpose of the explain statement in Teradata SQL? The explain statement in Teradata SQL is utilized to provide a roadmap of how the Teradata database will carry out an SQL request before you actually run it. This can be incredibly helpful when trying to optimize your SQL queries, as it allows you to see the steps that the database will take in order to complete the request. The explain statement can show you things like what tables it will access, if it will use any indexes, how it will join tables together, and much more. The output can be a bit tricky to read if you're not familiar with it, but once you understand it, it can be an invaluable tool for SQL optimization. 23. Explain the concept of transient journaling in Teradata. Transient journaling is an essential mechanism within Teradata that ensures the integrity of data during transactions. Suppose a certain operation is in progress, and it gets interrupted due to any reason, such as system failure. In that case, the transient journal holds the before image of the data, allowing Teradata to roll back the changes to its previous state, thereby avoiding any data inconsistency or loss. It's a temporary space, which gets cleared once the transaction is completed successfully. The transient journal resides on each AMP and records the before state of the rows affected by the transaction. If the system crashes in the middle of the transaction, the transient journal helps in restoring the system to the state prior to the initiation of the transaction. This feature of Teradata provides a great advantage in terms of data security and consistency. 24. How does Teradata handle data recovery in case of node failure? In the event of a node failure, Teradata employs a mechanism known as fallback to ensure data recovery. Fallback is a data protection feature that creates duplicates of each data row across multiple AMPs. When a node fails, the system can still access the required data from the duplicated rows on the other AMPs. This process is automatic and transparent to the user, ensuring continuous data availability despite hardware failures. Additionally, Teradata uses a transient journal, a feature that records all changes made to the database. In case of transaction failure or system crash, the changes can be rolled back or rolled forward using the transient journal, thereby maintaining the integrity of the data. 25. What are the best practices for optimizing query performance in Teradata? Teradata performance optimization can be achieved by various methods. Firstly, maintaining statistics on tables is important. This helps the optimizer make intelligent decisions about the best plan for executing a query. Secondly, using primary indexes efficiently can greatly improve performance. Make sure the index is on a column that is frequently used in the WHERE clause. Thirdly, avoid using too many joins in a single query. Break up complex queries into simpler ones if possible. Lastly, using the appropriate type of table can also have an impact. Multi-set tables can perform better in some cases compared to set tables. Remember, understanding the data and how it is accessed is key to optimizing query performance in Teradata. It's important to monitor and adjust your strategy as necessary based on the needs of your application and the performance of your queries. Hopefully, these top 25 Teradata interview questions and answers will assist you in preparing for your upcoming interview. The questions we have covered range from basic to advanced, aiming to equip you with a comprehensive understanding of Teradata. Remember, the key to success in any interview is the depth of your knowledge and the confidence with which you present it. If you found this video helpful, please like it and subscribe to our channel for more insightful content. Best of luck with your interview.